Hello everyone, welcome to Creative Point. In this video we are going to calculate CFM inside the rectangular duct or circular duct. That's why please connect with us so that you know everything by details how to calculate CFM inside rectangular duct or circular duct. Okay, now after please like and subscribe, and also comment what kind of video you want. In this video we are going to describe, calculate how to CFM and inside circular and rectangular duct. So please connect with Creative Point so you know everything easily and very simple way to how you calculate the CFM. Hello everyone, welcome to Creative Point. Today we have another instrument, and this is called Fluke airflow meter. From this meter we are going to calculate the static pressure, differential pressure, flow volume and velocities inside the duct, or we can check the differential pressure across coil, filter or blower. Okay, as you see, when I open the instrument, this is the main device. This is airflow meter. Okay, this is airflow meter Fluke 922. The model number is 922. Okay, from this device we calculate the CFM, static pressure, velocity and flow volumes. Okay, for the velocity we are take the different sample by pressing the save or enter button. Okay, for the flow volumes there is two sample, either the duct is rectangular or circular. According to your duct we can take the flow volume, they give you the CFM value directly. Okay, or for the clear all, we have to press the yellow button, and after that clear all, the sample is clear. Okay, for different flow sample we can just press the save button so that our data is in save. Okay, after that we have to make it average so that we can take the average CFM inside the duct. Okay, now we have another, we can clear the all data. Okay, for the maximum and minimum, for pressing the maximum and minimum we can check the how much maximum flow and how much the minimum flow inside the duct. Okay, we can check, and there is average also, we can take the average value inside the duct for all sample, all saved sample. Okay, for the unit we can change the unit by pressing the unit button. Okay, in the pressure we can take the different unit, either Pascal or of S2O or inch of S2O. Okay, we can also change the unit for the flow volume, so we can change from CFM to liter per second. We have as per your requirement. For the temperature, either we set it into centigrade or Fahrenheit as per your requirement. And the size of duct we can take is centimeter, meter or feet as per your requirement. Okay, from the upside there is two pressure hoses, one is positive pressure hose and another is negative pressure hose, and third one that is in the middle, that is a temperature sensor. This temperature that take temperature or area temperature. Okay, not inside the duct. There is two pressure hoses, one is yellow and another is black. The yellow one we connect that yellow one into the positive pressure side, and negative black one into the negative one. Okay, for the velocities and flow volume we have to require the static pitot tube. Okay, this hole they give you the static pressure, and that is connected to the device. This is the main hose, this is for they give you the dynamic pressure, and that one is the this one is for the static pressure, and another one is for the dynamic pressure from inside the duct. Okay, they give you the dynamic pressure. Okay, now we are going to connect the yellow hose to the positive pressure side, and the black hose into the negative pressure side. Okay, after connecting both pressure hoses, the positive and negative, we can take the differential pressure across the filter. In filter side there is a pressure drop, that's why we have to connect the positive hose before the filter and negative hose after the filter. Okay, after that we can take the reading differential pressure across the filter. And similarly we can take the differential pressure across the coil also. Okay, before the coil we have to connect the positive hoses, and after the coil we have to connect the negative hoses. Okay, for the blower side, before that one is increasing, okay, in blower, that's why we have to connect the black hose before the blower, and after that the positive hose after the blower, so that we can take the different differential pressure reading. For the velocity and flow volume, we have to connect the static pitot tube. Okay, from this tube we can take the different velocities and flow volume inside the duct. Okay, after that suppose we are going to calculate the velocity, that's why we have to connect both hoses, positive and negative, and then we have to take the reading sample from inside the duct. We have to take all sample, different sample, and with different position. After that we have to make it call average. Before taking we have to reset the sample, because if there is before there is sample we have to reset all. Okay, suppose we are going to take the velocity inside the duct. Okay, first we have to make it 0 sample, and after that we have to, for 0 sample we have to call reset all the data, previous data. Okay, first we have to press the yellow button, and after that we press all clear, so that the all sample is clear. Okay, after pressing the enter button we are calculate the 0. After that we are taking the different reading, different sample inside the duct. After that we make it average velocity, and that's why they give you the average velocity inside the duct. Okay, and after that for the flow volume, we can take the different velocity inside the duct. Okay, now for the flow volume. Okay, in flow volume we can take the direct CFM value inside the duct. First we have to select the samples, which kind of sample, either rectangular or circular. We have to, if it is, now we are going to calculate the CFM inside the duct. Okay, if you have the velocity, we have to take the velocity. After that we are going to calculate the CFM inside the duct. Okay, suppose that our duct type is rectangular type. Actually this is the cube, but this is we have to take the cross sectional area. Okay, suppose this is our rectangular duct. Okay, the flow towards, as you see, the indicated the flow, this is the flow direction inside the duct, and we have to take different reading inside the duct. Suppose we have to take 4 readings, we have 4 holes, that's why we have to take all the reading. If we take each hole 4 reading, that means there is 4 hole, we have to take 16 reading, 16 different reading for the velocity, and we have to connect the static pitot tube through this direction. Okay, that one, the arrow line, they give you the dynamic pressure inside the duct, and there is tangential. Okay, they give you the static pressure inside the duct. You know, for the velocity we have to take a reference point, we cannot take velocity directly. Okay, that's why we have to take pitot tube. Okay, in pitot tube there is 2 type of pressure, one is static pressure, another is dynamic pressure. Static pressure is the reference point, that's why the pitot is the scientist, he make this tube for the calculation of velocity and volume inside. Now we are going to calculate the CFM inside the rectangular duct. Suppose the thickness of the duct, the insulation in both sides, suppose that one is 25 mm, that the thickness for the rectangular duct. Okay, and we calculate the total length is, that one is 1200 mm. Okay, and 1200 mm. Okay, and suppose the height is height or width is 600 mm. Okay, suppose the height is 600 mm. Height, or we can also call it width of the duct, that one is 6, we take the 600 mm. Okay, And the exact flow length we have to calculate. How we can calculate the exact length? We have to minus the total thickness. There is, as you see, there is one is upside, one is downside. That's why exact flow length equal to total length minus 2 into thickness. Why multiplied by 2? Because the thickness is in both sides. That's why we have to minus 1200 mm minus 2 into thickness. Thickness is 25 mm. That means 1200 mm minus 50 mm, that is 1150 mm. The length is 1115 mm. Okay, now for the width we have to minus the thickness for both sides. The total flow width is equal to total width minus 2 into thickness inside the duct for the insulation. Okay, that means our total length, total width is 600 mm minus 2 into 25 mm equal to 600 minus 50 mm. Now the flow width equal to 550 mm. Okay, now for the for the CFM we have to convert the both length and width into the foot. Okay, so that we can take calculate the CFM value. Okay, now the foot we have to calculate it into foot. Okay, as you see, the length is 1150 mm. Okay, after convert we found that 3.77 feet. Similarly, we have to convert the width of the duct also. The width is 550 mm and that one should be convert into feet. Okay, after convert we found that one is 1.8 feet. Okay, now we have to calculate the cross sectional area. Okay, area or cross sectional area inside the rectangular duct. Okay, our sample is rectangular, that's why area of the cross sectional area is equal to area of the rectangle. Okay, and as you know, the area of rectangle is equal to L into W. Okay, our L is 3.77 as you see, the L is 3.77 into 1.80 feet square, because both is in the unit is feet, that's why feet into feet equal to ft square. Okay, and after calculate we found that one 6.786. okay, the cross sectional area is 6.786 feet square. 6.768 feet square. Okay, now we are going to calculate the CFM. Okay, for the CFM, suppose we take the flow velocity inside the rectangular duct. Suppose the average velocity we take through all sample, after that we call it average, and that's why we have to need it average velocity. Suppose that one is 1200 feet per minute. Suppose the velocity is average velocity is 1200 feet per minute. Okay, now for the CFM is full form of cubic feet per minute. That means how much cubic feet through the rectangular duct is crossed in 1 minute. Okay, and that should be how we can calculate. We can calculate CFM equal to velocity into cross sectional area of the duct. Okay, as you see, the velocity is 1200 feet per minute into 6.768 feet square. After calculation, now we are going to calculate both the velocity and multiplied by 6.786 the cross sectional area, and that we found that 8143.2 feet cube per minute. That feet cube per minute equal to CFM. Okay, they give you the CFM. The approx is how much? 8144 CFM. Okay. For the calculation of tonnage, how we can calculate the total capacity? We know that 1 ton equal to 400 CFM for chill water system. This is approximately 350 to 450. That's why we make it average. Suppose the say 1 ton equal to 400 CFM. The total capacity equal to total CFM divided by 400, the unit ton. Okay. 8144 divided by 400, our result is 20.6. That means approx 21 tonnage. This is the idea. We can calculate the CFM inside the rectangular duct. This is a simple and easy steps, so that if you follow this step, you can calculate the CFM inside the duct. Suppose we have another duct type. Suppose our duct type is circular. For circular, how we calculate the CFM calculation for circular duct. Okay, how to calculate the CFM inside the duct if the duct type, our sample duct is circular. Okay, suppose the total diameter for the duct is assume that one is 700 mm. Okay, this is just one example. That's why we take the total diameter is 700 mm. Suppose the thickness is 25 mm. One side is thickness is 25 mm. That's why inside the duct, how much diameter is coming? The total inside flow diameter equal to total diameter minus 2 into thickness. Why multiplied by 2? Because the thickness is in both side, both end, or both inside cross section. Okay, that's why we have to minus both side. After subtraction, we found the diameter is 650 mm. Okay, now we are going to calculate the cross sectional area. For every CFM calculation, we have to take the cross sectional area inside the duct. Okay, cross sectional area equal to area of the circle, and we know that area of circle equal to pi by 4 into diameter square. Okay, 3 pi by 4 into d square, diameter square. Okay, and we know the value of pi is 3.14 divided by 4 into 650 mm square. But we for the area we have to convert, not in cannot in put in mm. We have to convert this diameter into foot. The diameter should be in feet. Okay, that's why we have to convert 650 mm into feet, so that we can take the area in feet square. Because for the CFM we have to convert all the dimension in feet. Okay, for easy, that's why we have to convert 650 feet mm to feet equal to 2.13 feet. Okay, after calculation we have to keep the pi value 3.14 divided by 4 into 2.13 whole square. Okay, after calculation we have to calculate. Either you can use calculator or you can use from your mobile, so that we can for easy, or there is scientific calculator also available for your as per your requirement. After calculation we found that 3.56 feet square. The area is 3.56 feet square. Okay, now suppose how we calculate the CFM. Okay, we have to know the velocity. Let the velocity from the average velocity inside the circular duct. Suppose that one is 1200 feet per minute. That means the velocity inside the circular duct is 1200 feet per minute. It means 1200 feet per minute means the cross in 1 minute 1200 feet. Okay, and the CFM, as we know, the CFM is cross sectional area into average velocity, and average velocity. Okay, the cross sectional area equal to 3.56 multiplied by 1200 feet per minute. After calculation, we have to calculate both. We have to multiply 1200 into 3.56. After multiplied both, we found that one is 4272 feet cube per minute. The feet cube per minute is CFM, okay, because the CFM is cubic feet per minute. That's why we call it CFM, okay. This is the full form of CFM. That's why our CFM is 4272. Now the total capacity equal to total CFM divided by 400, because units 1 ton equal to 400 CFM. And after that, after calculation, we found that is 10.68, that means 11 ton. For this is the example for the. Thank you everyone for watching Creative Point. Please like and subscribe so that you can watch creative videos and technical video in Creative Point. And also please comment what kinds of video you want. Thank you for watching.